Hello everyone, this is Vardman and welcome back. We are going to learn another application of divide and conquer algorithm today. We are going to learn power of an element using divide and conquer. Input to the problem will be two integer a and n. A will be greater than 1 and n will be greater than or equal to 1. And output will be a raised to the power n. A raised to the power n is multiplication of a n times. We can see this program to find a raised to the power n. So we have our loop running from I equal to 1 and I should be smaller than n and I plus plus. So this program will multiply a n times. So we will get a raised to the power n. Let's understand with the help of an example. So we have a equal to 2 and n equal to 5. The initial value of p is equal to 1. We are storing the value of output in p. When the value of I is equal to 1, p will be equal to p into a, 1 into 2, which is equal to 2. For the value of I equal to 2, the value of p is 2 and p into 2 is 2 into 2, which is 4. Now the value of p is 4. Value of I becomes 3 and p into a is 4 into 2, which is 8. So the value of p is now 8. In the fourth iteration, p into 2 is 8 into 2, which is 16. And the fifth iteration, it is 16 into 2, which is 32. So the final value of p we got is 32. We got our answer as 2 raised to the power 5, which is equal to 32, and we used linear method to get the power of the element here. Let's find the value of 2 raised to the power 32, where a is equal to 2 and n is equal to 32. We will be following divide and conquer principle. So we will be dividing the problem into two parts and we'll keep on dividing until the problem become a smaller problem, and we will solve the smaller problem, which will be conquer part, and after that we will combine the smaller sub problem to get the solution of the larger problem. Now look at the example. 2 raised to the power 32 can be written as 2 raised to the power 16 into 2 raised to the power 16. This can be further divided. 2 raised to the power 16 can be written as 2 raised to the power 8 into 2 raised to the power 8. Similarly, now we will divide this also. 2 raised to the power 8 can be written as 2 raised to the power 4 into 2 raised to the power 4. Now 2 raised to the power 4 can be written as 2 raised to the power 2 into 2 raised to the power 2. And at last 2 raised to the power 2 can be written as 2 raised to the power 1 into 2 raised to the power 1. Now we get the value of 2 raised to the power 1. So this is the smaller problem and we do not need any further division. When the value of n is equal to 1, then that is a small problem. So this will be our base case. In the base case, we will simply multiply 2 raised to the power 1 into 2 raised to the power 1. This will be the value of 2 raised to the power 2. And similarly, on each level, we will do one multiplication and we can get the value of 2 raised to the power 32. Here we have saved some multiplication. So we only need to calculate the left part, as left and right part will be same. So we do not need to calculate again and again. So we will only calculating one side to get the final answer. When the power of element is odd, then we need to follow a slightly different approach. So here we have an example with 2 raised to the power 15. So we will divide it. So we will take the floor of 15 by 2, which is 7. Now we will again divide 7. So 7 by 2 and we will take floor, which will become equal to 3. And 3 can also be divided as 3 by 2 and we will take floor. So it will be equal to 1. So this will be our base case. Now in the combined part, we need to be careful. So whenever the value of n is equal to odd in the parent node, then we have to multiply an extra value of a. We have to find 2 raised to the power 15. So when we are multiplying 2 raised to the power 7 into 2 raised to the power 7, then we will also multiply an extra 2. So 7 plus 1 become 15. So we will get the value 2 raised to the power 15. Now let's look at our pseudocode. So we have our power function and we are passing a and n as input. First we have if condition. So this is our base case. When we have the value of n is equal to 1, so we have a raised to the power 1, so we will simply return a. In the else part, we will first calculate mid. So mid is n by 2 and we will take the floor value of it. Now we call the function recursively for the value a and mid, and we will store it in variable half. Now the next part is the part where we take care of the odd value of n. So if n mod 2 is equal to 0, so we have the value of n is equal to even. So we will simply multiply half into half and will return. Else if the condition fails, so the value of n is odd, then we will multiply a and half into half and return it. Now let's see the time complexity. So the if part will take only big O of one time because there is one comparison, and the else part, so we are dividing it every time by 2, so this will become t n by 2, and everything else will take big O of one time. So finding mid will take big O of one time, and this return statement, so this is a combined part, so this will take big O of one time. So the final reconciliation will be tn equal to tn by 2 plus c. So these all big O of 1 can be written as c, and when we solve this, so this will be equal to big O of log n. So you can see in the tree, so the function is called a total of log n times, and the number of level will be here log n. So for 2 raised to the power 8, when the input is n, which is equal to 8, so we get number of function call as log 8, which is 3. So you can see we called for 2 raised to power 4, 2 raised to power 2 and 2 raised to power 1. So we get a total of 3 function calls. The space complexity here will be the stack space, which is used to store the number of function call. So here we are creating log n function calls. So log n amount of space is needed. So space complexity will be log n, which is equal to the number of level of the tree. So I will write it. Time complexity will be log n, and space complexity will also be equal to log n.